good morning, good afternoon, and good evening, depending on where you are in the world. Welcome to the next session of the 2024 IIoT World Manufacturing Days event, the Insight Factory, Driving Decision-Making with AI and Machine Learning, sponsored today by Cirrus Link and GE Vernova. My name is Hamish Mackenzie, your moderator for this session, and as you'll know if you were in my last session, I'm currently joining you live from my vacation on the French Riviera, just down the road from the Cannes Film Festival, which is taking place as we speak, just over there. And I can confirm that Spielberg and Tarantino have both been on the phone saying they're tired of all the champagne, red carpets, and can they please come and join us for this session? Unfortunately, I've had to turn them down because we are booked, and for a very, very good reason, because this session is tailored for manufacturing professionals seeking to leverage artificial intelligence and machine learning to revolutionize their production processes. Now, we all know the industry thrives on precision, efficiency, and innovation. And we're going to be focusing on how AI and ML can help with all those things, can help transform raw data into a strategic asset, optimize operations, predict maintenance needs, and streamline supply chains. We're also going to be looking at the practical applications of all these technologies and how they can drive productivity, reduce costs, and improve product quality, helping manufacturers position themselves for success. So we've got an awful lot to cover, and I'm very keen to introduce you to our guest speakers today as well. Before I do that, we've just got a couple of bits of housekeeping to get through. Please do drop in the chat who you are, where you're from, why you're here. Helps us get a feel for who's in the audience. The session will last just shy of an hour, and I'm going to be introducing our guests, as I said. We'll then be getting a lot of valuable insights from them, of course, but we'll also be handing it over to you, our audience members, to answer your questions and get through as many of those as we possibly can by the end of the session. And whichever ones we don't get to, we will make sure we get back to you after the event to address any of those questions that we didn't get to in the session. Please do me a favor, put all your questions in the Q&A part of the tool, not in the chat. It just makes it easier for me to find them, and it's more likely you'll get your question answered if you use that Q&A function. So please do that, and don't wait till the end. Start getting your questions in all the way through the session, and that will, again, make sure that you don't miss out and help ensure that we get to your question. All right, with that said, I'm delighted to say we've got 4 expert panelists with us today, and I'd like to give you a quick introduction to them now. First up, we have Arlen Nipper. Arlen is CTO and President of Cirrus Link Solutions, one of our sponsors today, and he brings over 40 years of experience in the SCADA industry to Cirrus Link as President and CTO, as I said. He was one of the early architects of pervasive computing and the Internet of Things and co-invented MQTT, which, as I'm sure most of us who are here know, is a publish subscribe network protocol that has become the dominant messaging standard within IoT. He's worked for Amoco, Koch Oil, and served as President and CTO of Arcom Control Systems and Eurotech Inc. And his experience covers a very broad range of technology, as you can imagine, from the design and manufacturing of embedded systems right through to SCADA system infrastructure implementations. So welcome, Arlen. Thank you for joining us.
Thank you.
Next, we have Cobus van Heerden, who's Senior Product Manager, Analytics and Machine Learning at GE Vernova. Cobus is a Senior Product Manager for Analytics and Machine Learning software. He has 20 years of experience in developing and implementing industrial software globally. And he specializes in helping industrial organizations realize transformational productivity gains through applying digital technology, advanced analytics, and machine learning. Great to have you with us again, Cobus. Next up, we have Mike Tomasco, who is former VP of Digital Manufacturing at Pfizer Digital. Mike served as Vice President, overseeing the digital transformation of the Pfizer Global Supply, the vital manufacturing and supply and operations arm of that massive pharmaceutical giant, who I'm sure we all know. In that role, he harnessed his expertise in digital technology, AI, operational excellence, and continuous improvement to really revolutionize the end-to-end processes and performances of PGS. And prior to assuming that position, he held influential leadership roles in strategy, digital transformation, finance, and business technology across the Pfizer organization. And he says his overarching mission is to propel innovation and foster a culture of excellence within an organization, driven by the transformative power of digitization and data-driven insights. So thank you for joining us, Mike.
Thank you.
And next up, we have Tim Gauss, who's Principal and Smart Manufacturing Business Leader at Deloitte. He has more than 25 years of supply chain experience with a focus on value chain optimization. using emerging technologies like AI and ML, of course. And he has led multiple supply chain transformations over the years, spanning supply chain strategy, manufacturing optimization, supply chain planning, inventory optimization, operating model design, and operational excellence for domestic and multinational corporations. He's also been hands-on creating the factory of the future for his clients using IoT, converging the IT/OT space and harnessing edge to cloud to drive real-time insights. And he previously led Deloitte's US supply chain, retail, and consumer product practice. So welcome, Tim.
Thanks a lot.
And finally, a few words about me, your moderator. My name is Hamish McKenzie. I'm a former IDC analyst, and I've been running my consultancy, coaching, and advisory business from Munich in Germany since 2006. I work with software CEOs and senior executives to help them refine their positioning, set their strategy, and above all, improve their growth efficiency across their business. I also work as a coach and sparring partner, helping CEOs and other executives develop their leadership capabilities as well. If you'd like to know more about me, please look me up on LinkedIn. I'm pretty sure I'm the only Hamish McKenzie on LinkedIn in Munich. There are a few others out there, but not in Munich as far as I know. So it shouldn't be too hard to find me. Quick reminder to please get your questions in the Q&A function, not in the chat. It will really help me find them and make sure you get your question answered. All right, so with that all said, let's get into it. And I want to start off by setting the scene, if you like, setting some context. And I'd like to start off with Mike. So you spent 7 years leading this digital manufacturing transformation within Pfizer, Mike. And I know that you like to speak about the importance of having a strong foundation when you go into one of these projects, digital transformation projects in particular. Can you just speak a little bit about what you mean when you say that strong foundation? What does that actually mean for you?
Sure, absolutely. I think that the most important thing in my experience in having done this is to think about what you're trying to accomplish, right? You need to have a vision and strategy for the short, medium, and long term of where you want to go. But more important is once you have that set, and that's a constant evolution to keep that up to date, but once you have that set, you need to understand where you're starting from. What people do I have in my organization, whether it's in my manufacturing operations or my quality operations or my IT organization? Who do we have? What do our processes look like? We all know the adage of garbage in, garbage out. So if you go to digitally transform a bad process, guess what? You still have a bad process. You just might have more data around your bad process. And then ultimately, what technology foundation do we have in place? Do we have core foundational systems that help us run our operations? For example, do you have a standard globalized ERP that everyone's using the same way? Highly likely, even if you have a standard system like that, they're not all using it the same way. So you have to start to understand the intended usage and how things are going. What's your equipment look like? Is it connectable? That's kind of the number one thing that we've always talked about. We learned over time was, if we can connect our equipment, we should be doing that. And if we can connect that and store data with its context, that becomes useful later. And there's a lot of different strategies. You'll hear everyone talk about how to do that and when and why. But if you're going to make a single investment up front, know where you're going and understand where your data can come from, because that's the only way you're really going to be able to transform operations. It's kind of not a good idea to necessarily jump straight to AI or Gen AI without understanding these basic foundations. It doesn't mean you can't do certain things, but it means you might be much more successful in your approach if you understand the basics. So with all that being said, what problems are you trying to solve? That's like my last bit of advice there is like, know what you're going after. Don't try to solve every problem in your organization. There may be a very specific unit operation that's your bottleneck. Maybe you look at that first and do your pilot around that area and start to figure out, how do we bring this to life to then build the business case for scale up later? Thanks.
Right, exactly. So address a small area first, and then once you use that to help you understand, and then scale it up. All right. So Arlen, if I can come to you, I know digital twin is often another foundational element in one of these kind of transformation processes. So from your perspective, how important is it to create that digital twin strategy and enable the correct technology to deliver those twins within your current infrastructure?
Well, you have this. You say the word digital twin, and if you get different answers from everybody.
Yeah.
And we've worked with many companies in trying to leverage what digital twins are out there, the Azure digital twin or the AWS digital twin. And the problem with digital twins that are prepackaged is those probably aren't your digital twin, right? And so what we want to do is try to put together the technology to, like Mike said, to add the context to the digital twin that you want to end up in the cloud to work with. And so we've worked very hard in developing technology with MQTT, with the MQTT Sparkplug specification, which lets us establish a single source of truth wherever we're at. So those machines that Mike was talking about, if I want to publish those into a central location, I want that contextualized information from those machines, but I want them from the edge, because we have too many companies that are trying to create their quote digital twins up here in the cloud and then push them down to the edge. And as we all know, that won't work, because Joe will come in tomorrow and he'll add another transmitter, he may add another machine, and now we're out of sync again. And now we're in this vicious circle of trying to get our digital twins to match in the enterprise what's actually in our plant. So, really that's what we've been working on mainly, is our core technology is creating the MQTT technology to be able to publish that information into cloud infrastructure.
Okay, all right. And what I want to also do, just in terms of, I know there's a lot of buzzwords flying around a bit now, but I'm trying to set the the overall context here. Okay, so we talked about foundations overall. We talked about digital twin. Corbus, if I can come to you, Gen AI is obviously the big, huge buzzword at the moment in my world. I spend a lot of time working with sales, marketing organizations, but also leadership teams on strategy, and that means certain things to me and different things to them. What does Gen AI mean for manufacturers from your perspective, Corbus, and what are the particular areas of opportunity that you see in manufacturing?
Hamish, thank you. And hi, everyone. It's fantastic to be with you. So, I have, so as you might know, Gen AI it's an acronym for generative AI. And it refers to products like ChatGPT, and there's a lot of them out in the market already. But I've just gone and I asked the latest version of ChatGPT for a definition of generative AI. And so according to ChatGPT's latest version 4.0, generative AI, or Gen AI, is a subset of artificial intelligence that focuses on creating new content, so generating content, rather than simply analyzing or processing existing data. It uses machine learning models, particularly those involving neural networks, to create text, images, audio, and other forms of media. So generative AI has the potential to revolutionize various industries by automating content creation, enhancing creativity, and providing new tools for innovation. So that is what Gen AI thinks about itself, essentially. But I think so that sort of just level sets us a little bit. It's about what Gen AI is, but what is important is it is really a subset of AI. Okay, so I think, Hamish, my view is that Gen AI, but more broadly speaking, artificial intelligence and machine learning and other broader optimization technologies have now matured to a point where it really has the promise to make people as well as machines in manufacturing enterprises much more productive across all the stages of the design, make, sell, and service product life cycle stages of manufacturing, really, and across the manufacturing supply chain. And so if we just look at those different stages, for example, so in the design stage of a manufacturing enterprise where you are designing a new product, I think these AI tools, and especially generative AI, really has the potential to help you come up faster, to assist your people to come up faster with more innovative, durable, and sustainable designs. And ultimately, in that sense, accelerate time to market, so to speak, for new product designs. Then if you look at the make phase, so you have to now produce these products, manufacturing them. I think for me, there's two things. These technologies have the ability to optimize production planning and scheduling. So basically optimize your supply chain, so to speak, and planning and scheduling of production. But then secondly, also optimal execution of production. So once your factory, starts to make a specific order of a specific product then make sure that is made at optimal efficiency. What does that mean? It means, higher efficiency, higher quality, lower cost, less energy use, less material, raw material use, faster, more people productivity. I mean, if you just ask yourself for a factory that's often measured in a, with a metric called OEE, overall equipment effectiveness. So what that means is if the factory runs at 100%, it means every product you make, you're using your machines 100% of the time. All products are perfect quality, and you're making, you're using 100% of capacity, your production capacity, essentially. The truth is, average factories out there runs around 65%, and world class is 85%. What does it mean? It means that if you can increase, if you are a 10-plant enterprise and you can improve the productivity of each plant by just 10%, you've unlocked a whole new production plant that you didn't have to build, essentially. Then if we move on to the sell phase, right, you can do things like forecast demand better. For example, predict and forecast demand, and really maybe even match pricing to demand. So price dynamically based on demand. Pricing and just sort of planning your production in that sense. Then if we move to the service, now you sold, the product is out in the market and you want to sort of service it, you can get to also remote or self-monitoring and diagnostics of those products to monitor how are customers using them. Are they satisfied? Are they healthy, these products? Do they need services? So all of these things across all these stages, these are the types of ways in which these technologies can squeeze out additional benefit for both customer and manufacturer.
All right, fantastic. Thank you, Cobus. And so maybe we can now go to Tim, and I think he has some views on what he's seeing out there in the marketplace, because he had this broader perspective, obviously, from Deloitte. What are you seeing, Tim, in terms of how manufacturers are starting to integrate generative AI into their actual operations?
Yeah, so I know that we all see the hype around generative AI, but I'm actually quite bullish on the impact this is going to have to manufacturers. Mm-hmm. And it's one of those technologies that I'm seeing really quick and rapid adoption. And I would encourage everyone on the line to really highly consider this. Everything Cobus laid out, completely agree with. But the starting spot I'm seeing most common is actually around the human side of our operations. Uh-huh. At the end of the day, manufacturers still are not lights out and likely won't be lights out for quite a bit of time. Yet our workforce is aging out at a very rapid pace, and the ability to bring people into our workforce is both challenged because it's not necessarily the destination it once was, and two, the skill sets coming in are a little bit different. So generative AI actually can really help tackle that problem, both from the kind of a way you can access knowledge that sits within the organization, put it in the hands of the people on the plant floor, of your supervisors, and really help curate a better, more rapid onboarding. Think about having your best technician ever, with his knowledge put into a model that anyone who wants to ask a question can actually basically virtually talk to your best technician ever. Those type of relatively simple problem-solving techniques where you're answering questions and you're curating knowledge is where I see most folks starting their generative AI journey. And with that, I think you're going to see a lot of very natural extensions. One small example, a client who we work with extensively has lost a lot of their data analysts. And so they just don't have the time to go through and analyze all the data they have. They have a lot of rich data, but this helps them actually just access that in a very human way to say, hey, what's the best, tooling to asset combination to maximize my OEE? Well, the generative AI can look through that and basically can come back and answer that question. So I'd say it's really on the lower end of the complexity where I see people starting, but there's a huge amount of value because you're helping the aging workforce issue that is endemic to manufacturing.
Okay, fantastic. And we're going to come on to some of the, to how things may evolve, going forward. So let's carry on getting even more practical now. And I wanted to come back to Cobus and ask you, what are the key considerations then, assuming that you want to start using these AI, ML technologies, whichever ones they happen to be? What are the key considerations for making a success of your deployment? And where are maybe some of the quick wins that are gonna emerge from doing that?
Hamish, I think Mike spoke about foundations. I really liked what he said, so totally agree with all the foundational sort of considerations he mentioned. I would, as I outlined the sort of design, make, sell, and service, let's say, stages of manufacturing, where I think there is benefit to be had in increasing productivity of both humans, as Tim alluded, as well as machines. With these technologies, I would like to focus in my response on this question to the make, and specifically the make stage where you're manufacturing and producing products, but specifically in the production execution, which is where, production planning execution, where also G-Vernova, where we help customers a lot, and we have a lot of experience. We're seeing how customers are running their manufacturing plants, so to speak. I want to talk about the considerations for using these technologies in optimizing production execution. I mentioned that I think on average, the average factory out there probably runs somewhere around 65% OEE. World class is 85%. And, think about the implication if you can quickly add 10% through optimization of people and machine productivity with these tools all your factories in your enterprise. What would that look like to provide better throughput, better quality of product, lower downtime, lower energy material usage, for example, maybe less emissions, and just run more sustainably. But in order to do that, I think to start with the foundations, it's really important to come back to what Mike said. So I would say, make sure your foundation is right. For me, that would be, you need the right automation in place. I mean, think about the traditional levels of automation, reliable, scalable industrial automation and production software. You need your level 1, 2, 3, 4, from your PLC, DCS, your SCADA in place, production software like manufacturing execution software, MES, make sure that is in place all the way up to ERP. So those layers, those foundational systems that eventually produces the data and facilitate and run your operations, you have to have that in place before you can optimize, I would say. Secondly, the data. You have to have good data, the junk in, junk out principle that Mike alluded to also. Have reliable industrial data collection and management software in place that can really collect all this data from the various OT systems, combine it, what I call across the value chain. So in other words, it can combine, let's say, your raw material data with your sensor data, with your production context, all the way through to final product quality. All the OT data combined in context across the value chain. So data, quality data combined in context across the value chain, properly managed with proper scalable, reliable, I would say, data management software layer is really, really important. Those are systems like, process historians and, MES systems, and, those sort of software can help you not only generate, but manage some of that data. And then thirdly, or next, I would say, now you can, when you have those foundations in place, you can think about deploying or layering, applying reliable and scalable AI ML software with the purpose of optimizing processes and supporting optimal decision making using your available data. But make sure the capabilities you layer have the ability to go all the way to closed loop, real time, high speed autonomous control where it's safe and feasible. So what do I mean by that? I agree. Tim said, hey, we're not there yet, lights out. But so you have to start with the end in mind. In other words, ask yourself, when you layer these products and start to use these technologies, where do you want to go? Some processes are safe and feasible to automate, but some others not. And it's better if you just support the decision making of the people and the person in the loop. So yeah, layer then these technologies, make your choices carefully. And also think of, for example, you want to go to high-speed autonomous closed-loop control. Where should that run? You can't just have technology running in the cloud. Ultimately, these AI ML models or algorithms, optimization algorithms, has to be able to run where it matters. Some in the cloud, some on-prem, some close to the edge for high-speed closed-loop decision-making. And lastly, I would say just look out when you look at these capabilities, look for 5 key capabilities, which I refer to as analyze, monitor, predict, simulate, and optimize. If you think about it, there's opportunities where these technologies can help you just interact with your data and analyze and ask questions differently, meaning why did this happen? Why did that happen? Real quick. So it's like having that best operator always on duty. Secondly, monitoring. You can layer these technologies to be like a watchdog, to keep a permanent eye on all layers of your operations, from sensors to equipment to process to control loops, and early detect any anomalies before a human can and sort of still detect it. So that's monitoring. Prediction, I mentioned before, it can look ahead in future and forecast or predict quality or anticipate downtime. So you can use these AI ML for prediction and forecasting. Simulate, that means you can create, we refer to digital twin models. In my mind, I refer to some of these simulation models as, mathematical or let's say models that simulate the behavior of your process or specific asset. These technologies can create those models, allow you to do what-if analysis, meaning you can ask questions, what will happen if I change the setting? Will it be better? Will it be the best setting? And so just support better decision-making faster. And then lastly, optimize. You can deploy optimization algorithms that can go with closed-loop control, automatically adjust where it's safe and feasible settings in your plant and process, and in that way, squeeze out significant margins of throughput and quality. So yeah, analyze, monitor, predict, simulate, optimize. Look for these kinds of capabilities in AI ML software that you can layer to help you really optimize production execution in your plants and push closer to that 100%. If we can get to 100%, I think it's probably, I'm not sure how feasible that is, but like I say, 10% in 10 plants is one whole plant you don't have to build.
Yeah, no, absolutely. And that's a very powerful image, I think. I like the fact that you also, a few minutes ago, also introduced the people aspect into this, and we're going to be coming back to that later on, because I think it's important never to forget that the people aspect is a lot of these projects fail or succeed based on exactly that element. Nevertheless, you talked a lot about data there, and we have to face the fact that that data is complex and managing it is complex, and we have to find better ways of extracting meaningful value from it. And I know, Arlen, you have some thoughts around, the critical issues around that complex data, and also how we can move from data swamps, particularly within the contextualized digital twin aspect of this, and how we can leverage standards like MQTT Sparkplug to help with that. So maybe you can talk around that a little bit, please.
Sure. So with 46 years of industrial experience, I still remember when we were happy when we could upgrade from 300 baud modems to 1200 baud modems to get our data in. And, at the end of the day, I started with Coke oil, and I learned how to hook up 4 to 20 milliamp transmitters, and why does a motor operated valve have a limit switch on open and a limit switch on close, and all of this stuff, this physical stuff that we're working with. So before we try to model it, I think we have to understand it and get an interface to it. So a lot of my, work over the years has been protocol converters, taking the flow computers we've got, the PLCs that we've got. Now we've got emerging technology like LoRaWAN sensors that you can just pop onto all of your brownfield equipment. We've got, really advanced PLCs that are coming out to be able to talk with those. So we offer technology to be able to take as much of that process variable information. Now that could be binary, it could be floating point, it could be uh, uh, integers, strings, whatever, and try to build models, like you said, Hamish, within Sparkplug, and publish those MQTT into cloud infrastructure. And from there, we're starting to get, like you said, with Snowflake, now we've been able to publish that data. We've got context, we've got the structure of the data, and now we can immediately start running AI, ML, LLM on top of that data. And again, keep that single source of truth coming from the edge, coming from all of that equipment out in the field, and then having the capability to do store and forward. We know that we've got cellular, we've got microwave, we've got VSAT, and then we can get to fiber and Ethernet and all that. But we've got to have mechanisms like store and forward. If I lose my cellular, if I lose my VSAT connection, be able to reliably make sure we can get that time series data back into our cloud infrastructures, and then be able to run analytics and things like that on those. So again, I think it's all of this technology we're talking about is great, but we still have to go down to that level one and interface to that equipment and get that information up before we can do any of this cool technology.
Absolutely, and so we're going back to foundations again, really. And as I mentioned a minute ago, part of that foundation is also it involves the people. And I know, Mike, you've got a lot of experience of setting these things up in the real world. And for some stakeholders, particularly at senior levels, I'm guessing they don't necessarily understand the importance of the boring foundation work that needs to be done, and they just want to get started and start using these tools. So in terms of setting expectations for those stakeholders who may have that attitude, how do you do that so that the people don't start running off and start doing random things without any structure behind it?
I am almost certain that just about everybody who joined this session has one or more senior executives who, saw ChatGPT come out, just like the rest of us, and went, wow, that's amazing. This is going to do so many things for us, because you can start to just dream up different things you think might be possible without really thinking about how or the consequence of just jumping straight into stuff. And that's exciting. That's a great thing. It's great to see new technologies come out and say, wow, that's amazing. One of the things I've definitely felt and seen firsthand was that excitement juxtaposed with the reality of where you're at in the journey. Right. So if you're on this long-term journey for how are we going to constantly evolve our operations over time, new technologies are coming out every day. As far as I'm concerned, Gen AI, as exciting as it is just another tool in the toolbox. And if I don't have these basic things, Kobus was talking about an MES system. If I don't have my MES system up and running and helping my shop floor operators do their work and collect high quality data, layering in the Gen AI technology isn't going to be as useful, right? So all of a sudden you have this expectation mismatch on the art of the possible versus the reality of where we're at today. And I think that in that situation, very practically for me and my experience, trying to teach myself and my team members to listen first and then just be empathetic with the situation that you're hearing. There's a desire to do things quickly, to save cost, to expand market share, to make more product faster, higher quality. All these things are desired outcomes, but you've got to really listen to the underpinning of what's the real driver behind that? What's your business driver at the highest level to try to help you do that? And then when you start to listen and understand and put yourself in your, let's call it business partner's shoes, if you're on the IT or the OT type side, you start to go, okay, how can I help make this a reality as a team? And what partners can I also bring in to help me make this a reality? I have a certain skill set. I understand where our people are and what we can do. I know what I might need to bring in. I also know how much it might cost. That's the talked about thing with Gen AI, especially. It's extremely expensive to do certain things with certain types of approaches. So you really just have to be judicious about trying to link together that desire and then the practical reality of what you need to go do. The other common thing that you might run into in this environment is in a digital transformation, a lot of what you're trying to do, we just talked about, you're trying to connect things horizontally across end-to-end processes. Kova's talked a lot about that. But a lot of our companies are set up in vertical structures, vertical silos. Like in my world, I've got a manufacturing silo that is taking things in from an R&D silo. And then I've got a quality lab silo that tests those things. And I've got a quality assurance silo that kind of works across all that. Then I have a supply chain silo that's trying to get everything out into the marketplace, right? When you try to connect those things up, you inherently have disconnects in strategy, most likely, as to what's most important to those silos. So digital transformation is all about breaking that down strategically and process-wise, and then enabling it with data to do things. If you just start to take some of the let's call it Gen AI tools and put it on top of that, it's going to get confused, right? It'll generate answers for you, but it might not be the most optimal answer. You're best off probably going backwards into your processes and saying, where do I have the biggest issues? We talked a lot about OEE before, right, Coves? And, there's a lot of value in making yourself more efficient at that unit operation perspective, and then starting to link up those operations. So in a biopharma process, you don't make a single product in a single plant, let alone a single unit operation, right? You're going across multiple plants, sometimes over the course of a year to make a finished good. That's how that works. So you have to be able to link all of that up and understand where you're at, and then look at those unit operations. And if you actually fix one, you apply certain AI technologies, machine learning technologies that fix an operation, make it more efficient. What does that do downstream, right? What does that do to your lab operations? If your lab operations aren't as efficient as manufacturing, you're just creating a bottleneck with work in process inventory. That's also very bad, right? We have to get to the point where we're smoothing out that end-to-end flow of information and product so that we can get it to the marketplace more expeditiously, let's say. And I think if you focus on going backwards and looking at those operations and how they're linked together, that'll play into your strategy of, how do I get from a silo to a connected environment into this predictive concept? And then ultimately, as we were talking about earlier, this real-time adaptive process world. That's like the holy grail for many, many manufacturing operations and that lights out concept. But it's hard. It's something you strive towards. It's not magic. It's hard work, right? And that's what we have to focus on a daily basis. And as you pick things out there, what you can start to do is build your value cases around, okay, let me do that unit operation capability. Where else in my organization does that specific solution scale to? How do I replicate that? And then how does that horizontal integration scale from plant to plant, process to process?
Okay, fantastic. Tim, are you still there?
It looks like Tim disappeared, yes.
He disappeared from my screen. Okay, so we'll...
Can you guys hear me?
Oh, we can hear you.
Oh, it's me back. There he is. Great,
Yeah,
fantastic.
That was strange.
Yeah, no worries. Perfect timing, Tim. So we've talked about some of the challenges, and as Mike was just saying, though, he thinks of Gen AI as just one tool in the box. So could you talk a bit more about how what the opportunities are in terms, Gen AI within the context of AI overall for manufacturers, as from your perspective?
Yeah, I mean, first I want to say I completely agree with Mike. It's just one other tool in the toolkit. Like, let's speak, tech is tech without the other stuff that comes along with it.
Yeah.
And also, if you talk about machine learning, deep learning, AI broadly, we've been doing that in manufacturing for a really long time. I mean, this is not a new concept for us in this space. However, one of the big failure modes I've seen over the years is the black box element of machine learning and AI, right? And the one of the major reasons people stop using those fancy algorithms is because they don't know why that algorithm recommended something, or they don't understand, was it a data issue or was it actual an insight that it was coming up with? So you have that challenge. And what I think Gen AI is going to present a very interesting opportunity for us is to drive much more explainability of the AI, because you can link those underlying parameters of your AI algorithms into a generative AI engine, basically query it, say, okay, what made you recommend that action? That brings the explainability that we've always been seeking with the machine learning in the manufacturing space. I think it's going to be a very powerful new tool in our toolkit as we kind of go forward.
Okay, we're kind of coming up, thank you for that, Tim. We're coming up against a little bit of time pressure. So and I want to make sure that we get into some real world examples now before we take some questions at the end of the session. So if I can come back to you, Arlen, I know, and you mentioned it before, CirrusLink has partnered with Snowflake to provide a unified namespace into Snowflake. Can you tell me a bit more about that and how that is going to help drive AI solutions for customers?
Okay, so imagine, I mean, that's the thing, is that as everybody's talking, and I know what, Mike, you know, imagine we've got a Modicon Model 200 PLC. It's 30 years old. We've got to get data out of that. Then we've got our newest Allen Bradley PLCs. Then we've got, you know, LoRaWAN sensors, and we want to get all of that information in context, everyone, into Snowflake in the using the Sparkplug schema, if we will, on Snowflake. Now, can you imagine that without writing a single line of code, we can take an entire plant and basically publish that plant into Snowflake with all the contextual data, everything that we described around that. And that means engineering high, engineering low, deadbands, scaling mode, all that information, not just the, oh, here's the process variable and the name of the process variable and the quality, but all of the other contextual data. So we've been able to take process variables and tie them to machines and tie machines to factories to build out this whole unified namespace. Now with Snowflake, we can run in with data in place and run AI on it. We can run ML on it. We can run LLM on it without having to move it. And that's the nice thing about Snowflake, is you're running all these processes. You don't have to move the data out to run your LLM and then move the data back in, which is a very expensive process. So we've been able to find out get projects up very quickly, because basically it's a no-code solution or approach, if you will, to model your data, publish it in MQTT Sparkplug, and now immediately start not say, okay, well, gee, we got it into our cloud database, but now we have to learn a new programming language to get it out of that. And then we've got to go into a data lake, and then we have to run these processes on that. And the thing I really love about Snowflake is that it's SQL. And I do these demos for IT. So here I'm an OT, and I do this demo, and this contextualized model comes up, and the IT guys, whoa, it's in SQL? And we go, yep, it is. So it's a very nice combination, and it's really helped us on a lot of projects get up to speed very, very quickly.
Fantastic. All right. Thank you for that example, Arlen. Mike, can I ask you to try and think of one, your best real world example during your experience at Pfizer where
I would
AI...
say, where was Arlen when I needed him 7 years ago? Because technology's changed so much in that 7 years. It's made doing what we're talking about so much easier than it was a while ago. A lot of what we had to do is kind of brute force put together those relationships in the model and build the communication channels and build our Snowflake models. And we had to do a lot of that ourselves. So, you can do it that way still, but now there's so many teams and capabilities out there that are building the capabilities to help you build that extension of your foundation, let's call it. So from a real world example though, very specifically, hardcore math is really important in the biopharma world. So when you're looking at your process capabilities, you're doing, basic algorithms and math first. And that's going to help you solve a lot of problems. What's really interesting, and Tim talked about this a little bit, is the experience of your operator. They can't necessarily interpret that chart. The process engineers can. In fact, if you put a Gen AI interpretation of some of that information and all that in front of a process engineer, they just kind of go, great, I knew that already by looking at the chart. But your shop floor operator all of a sudden doesn't have to be a process engineer to understand what that information is telling you. You can build an experience layering in Gen AI that tells you what's the next best action that I should take to optimize this process, drawing upon all of your history, all that real-time data, and the knowledge of some of your experts who might be leaving your organization. If you have captured that all in a way, that's where the creation of new content with Gen AI layered on top of these tool sets and that foundation you build over many years, most likely, creates a lot of value. And that's something that we've done, or my former team is still doing, I should say, with what we call a golden batch analysis with process parameters, using hardcore math, understanding things, and then layering on for the operator. What do I do next if I see this drifting, and keeping it in spec? So that's a real world practical application of this, built soup to nuts first in about 3-4 months, all the way into production, layering in the tool set after 15 years of foundation work.
Wow.
Right.
Okay. Yeah, that's pretty impressive. All right. Fantastic. Thank you. Kobus, one example from you?
So, hey, Hamish, yes, in GE Vernova, with our prophecy software and services business, we have been helping manufacturing customers for many, many years through our prophecy SCADA, Historian, and MES software, and also our analytics AI ML software, to really operate and optimize their manufacturing plants. Now, again, I focused my examples on production optimization. Typically, we see our customers improve throughput, yield, or recovery, or quality, or waste, now it's performance, by up to 10% or more within a plant or within a section of the plant, typically within 6 months, often first value in hours by gaining new insights, by optimizing the settings of their production processes using our AI ML software. And, just real quick, 3 examples. A food customer has recently reduced evaporator startup time by 20% by basically optimizing the startup settings of the evaporator. Now you can imagine the effect of that. The automotive part supplier has reduced factory hall energy usage by 15%, again by optimizing heating control settings. And then lastly, a mining customer of ours have increased throughput through their grinding circuits by 10%, by optimizing control settings. Now, all of these improvements through AI ML and optimization software directly have a significant impact on the customer's performance in their plants. Those would be my examples. Thank you.
Okay. Fantastic. I mean, those are significant impacts on the business, obviously. All right, Tim, I know Deloitte has several smart manufacturing centers, and there's one in the US called the Smart Factory by Deloitte at Wichita. I was wondering if you could tell us a little bit more about the factory, and then also perhaps one example from your world in terms of how one of your clients are leveraging AI and machine learning to improve their decision making.
Yeah, that's right, Hamish. So we have a global network of smart manufacturing facilities, and in Wichita specifically, we make a product that has the full implications of supply chain, because we felt that if you don't actually do something that's real, then you're just kind of pretending. So we wanted to have an actual production line. At the same time, you have to do, we're a consultancy, we shouldn't be in the manufacturing business, so we do it to actually donate STEM education kits to underprivileged schools. So there's a purpose behind what we're making, and we're pretty proud of that. But what's more important about these facilities is that we're able to take the concepts we're all talking about here and bring our clients to see them and experience them in advance of having to do it themselves and get the learnings that we've gone through. I mean, we run multiple ERPs, we run multiple MESs, we run a very complex set of technical stack there because that's the world that everyone lives in. You know, you can't have the privilege of a greenfield world. We have to model a brownfield world. And with that kind of backdrop, we can then show AI, generative AI, vision, AR, VR, all the things that we're exploring in a very real way on a real action functioning production line. So a very quick example, one of our clients, discrete manufacturer client, make a highly complex, highly engineered product with a multiple stage, very complex kind of interaction model that has a risk of quality defects that can occur at any one of those stages. And so what we did there was link together in that digital thread we've all been talking about, from engineering through execution, all the different work styles together, to monitor the parameters running on the edge, not in the cloud, trained in the cloud, running on the edge, to predict future quality defects and then proactively address them. Very successful. That in a single facility, single line, saving $20 million annualized and spreading across the network. We are also able to demonstrate that same capability in Wichita. And so that's the way we can work together to show real life outcomes, real life results, but then bring it back to anyone to see how it functions in our own space.
Fantastic. And that's exactly the kind of, hard dollar concrete ROI that companies want to see from these types of projects. All right, thank you very much, guys, for your incredible insights there, as usual. Really, really valuable. And as promised, I wanted to leave a few minutes at the end of the session to answer some questions. So this is where I'm going to put you on the spot, or rather our audience is going to put you on the spot. And I'm going to just pick a couple to go through in the last few minutes that we have. So we have a question from Carlos. What are the top 3 reasons why machine learning is not as widespread in industrial applications as it could be, from your perspective? And if you agree that that is the case, how can that be overcome? How can we get machine learning more integrated into these applications? Who would like to tackle that one?
I'll give you at least one reason. I think that oftentimes, and maybe it ties to the question above it too about small scale, like people don't necessarily understand where to start or how to start, or this sounds like a good idea, and then gaining the buy-in within your organization is difficult. If it's hard for you to articulate what it is you're trying to accomplish and the value it creates, you're not going to gain buy-in. I've seen way too many groups talk for a very long time in circles about doing things. And, you have to have an action-oriented bias, right? You can't have a let's talk about this bias. You've got to start somewhere, and every day you're not doing something towards this goal of trying to implement machine learning or AI or whatever it might be, you're losing time, because technology is also constantly changing. So by the time you justify something, technology might have changed 4 times and you're already doing something that's outdated. So you have to have that maybe vision first, and then a practical, how do I get from A to B to C? The technology is out there. It's now more the steps that you need to take in your own organization. And it's unique for everybody, right? Because that people, process, and tech thing, it's unique to you and your operation. You have to understand how to make that correlation between the desire to do it and actually doing it. It's that action bias that's really important.
I would totally agree with that, Mike. And I think we touched on some of the other challenges along the way too. The foundational elements that are required to make this all successful. The data, you have to have good data to make any of these things come to life. The one other thing I would add, though, to kind of complementing Mike's perspective is, if you don't think about the scalability when you start, you're likely going to have a regret. And you'll hear the phrase pilot purgatory. A lot of these AI and ML initiatives get stuck because you didn't think about how you take it to the next spot, and then you end up redoing the work. And that's when the cost profile gets out of hand. So in addition to all the things we talked about before, I would encourage you to think about scalability very early in your journey.
Absolutely. I might add to that. So, start with the end in mind. Choose a use case that's with very obvious POC results, like some of the numbers I mentioned, that no manager can disagree that is huge savings. Start with pick something which has a big impact on the organization. Maybe it's a problem all plants need to solve. Do a quick successful POC with good results, and then scale it. But then also I think the explainability story has been a big deal, that sometimes these things were just too black box for the use cases people picked. But I think we're getting to a point where we're starting to have the tools to make that more explainable. And if you, again, last thing I'll say, if you think about the analyze, monitor, predict, simulate, optimize, if you are going to control a plant with it, there's a lot of risk, okay? But it's very easy to apply it to analysis use cases where you help somebody gain insight quicker. I mean, there's not a lot of risk there. So just think about, don't pick the highest risk, most difficult thing. Think about scalability. Think about where you want to end. Those would be some of my comments.
All right, thank you for that, Corbus. One very quick one to end with from David. Where do manufacturers want to have their data processed with AI? On the edge, on private cloud, public access, segmented cloud? So where do they want their data to be processed?
It's all the above, right? It just depends on.
It's all the above.
Situation, right?
Yep.
Yeah. All right. Fantastic. Then I think we are unfortunately out of time, guys. Whatever questions we didn't get to, we will make a real effort to get them answered for you after the session. So thank you for submitting them. I want to say thank you to our speakers. Great insights, great knowledge, very impressive panel. Thank you very, very much. Thank you again to the sponsors, in particular Cirrus Link and GE Vernova. If it wasn't for you guys, then we couldn't hold these events. We wouldn't be providing all this great value to our audience. So thank you. Thanks again for all the audience listening, asking your questions. And it's now time to move to the next session in today's event, which is Fortress Factory, the critical importance of cybersecurity in the IIoT era, sponsored by Schneider Electric, Keyfactor, and Atlas. I have one more session left today in about an hour. I'm hoping my voice is going to keep going that long. I'm sure it will. Thank you again, and enjoy the rest of the event. Thank you, guys.